Right now, as you are watching this, the single number that drives more global weather than almost any other factor on the planet is sitting at 2.7 degrees Celsius above normal, and it is climbing faster than it has at this exact point in the calendar in the entire 45-year satellite record. That number comes from a patch of ocean called the Niño 3.4 region in the middle of the tropical Pacific, and it is the benchmark scientists use to measure the strength of El Niño, the periodic warming pattern responsible for reshaping weather across nearly every continent on Earth. As of this week, that number is already running hotter than the two previous record-setting El Niño events were at the same stage of their own development, hotter than 1997, hotter than 2015, the two events that currently hold the modern record for the most powerful El Niño ever measured. Independent analysis from Berkeley Earth, published just days ago, put it plainly. No prior year in the entire record has been anywhere near this warm and this early. Forecasters at the Climate Prediction Center now give this event roughly an 81% chance of reaching what scientists formally classify as a very strong event. And some of the most sophisticated climate models being run right now project a peak strength that would shatter the current all-time record by close to a full degree. This is the story of the huge weather shift now building beneath the surface of the Pacific Ocean, why it is developing faster than anything scientists have measured before, and what it is forecast to do to weather across the United States, Australia, India, and beyond over the coming months. No hype, no exaggeration, just what the data says, sourced directly from the agencies and researchers tracking it in real time. Drop a comment and tell me where you're watching from, because depending on where you live, this exact pattern is forecast to bring you either a much wetter winter or a much drier one, and almost nowhere in between. If you want grounded science coverage instead of vague headlines, subscribe. It is free. And A-like helps this reach people who need to understand what is actually building right now. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why one patch of ocean temperature can reshape weather patterns on the other side of the planet, you first need to understand what El Niño actually is. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, piling up warm surface water near Indonesia and the western Pacific while pulling cooler water up from the depths off the coast of South America. That temperature difference powers a massive loop of rising and sinking air called the Walker circulation, which in turn helps steer the jet stream, the position of storm tracks, and rainfall patterns across huge stretches of the globe. El Niño happens when those trade winds weaken or even reverse, allowing the warm water that would normally sit in the western Pacific to slosh back eastward instead, dramatically raising sea surface temperatures across the central and eastern Pacific, and in the process, flipping the entire Walker circulation into a different configuration. That single shift in ocean temperature is powerful enough to alter storm tracks, rainfall, and temperature patterns simultaneously across North America, South America, Asia, Africa, and Australia, which is exactly why a number, describing a patch of open ocean thousands of miles from any coastline, can end up mattering enormously to a farmer in India or a skier in Colorado. Scientists sometimes describe El Niño as one of the closest things the planet has to a single dial that can nudge weather on nearly every inhabited continent at once, which is precisely why a change of just a few tenths of a degree in this one specific patch of ocean gets tracked as closely as it does. Not every El Niño reaches the same intensity, and scientists have a specific formal threshold for the strongest tier, when the Niño 3.4 index reaches or exceeds 2 full degrees Celsius above. Normal at its peak, meteorologists classify the event as a super El Niño, a designation reached only a handful of times since detailed records began in the 1950s, during the events of 1982, 1997, and 2015. The 2015 to 2016 event currently holds the modern record, peaking at 2.6 degrees Celsius according to NOAA's own Oceanic Niño Index. The 1997 to 98 event, while slightly less intense by that specific measurement at somewhere between 2.3 and 2.4 degrees depending on the dataset used, is remembered as the most damaging El Niño of the entire 20th century, linked to an estimated 23,000 deaths and roughly $35 billion in global damage, according to NOAA's own historical archive. The event now developing in 2026 is being compared directly against both of those historic benchmarks, and by nearly every measurement scientists are tracking, it is currently outrunning them. The pace of this year's development is what has genuinely surprised the researchers, watching it most closely. This event only transitioned out of La Niña conditions in April of this year, and the jump since then has been described by multiple independent trackers as one of the sharpest La Niña to El Niño flips ever recorded, with the Oceanic Niño Index climbing from negative 0.21 degrees Celsius in the first months of the year to positive 1.39 degrees by early summer, and continuing to climb from there. By early August, subsurface ocean heat anomalies in the tropical Pacific, essentially a measurement of how much extra thermal energy is stored beneath the surface waiting to rise and fuel further warming, were already the warmest ever recorded for that point in the year, surpassing even the levels seen ahead of the historic 1997-98 event. Japan's own meteorological agency separately reported that July temperatures across parts of the tropical Pacific reached 2.5 degrees Celsius above normal, tying 1997 for the highest July reading in that agency's own record dating back to 1949. Put simply, virtually every independent measurement scientists have available, surface temperature, subsurface, heat content in multiple different tracking indices, is telling the same story from a slightly different angle. This event is not just strong, it is arriving unusually early and building unusually fast. It is worth pausing on that speed of transition specifically, because scientists studying ENSO cycles treat the rate of change almost as seriously as the eventual peak strength itself. The gap between the tail end of this year's La Niña and the current El Niño is the shortest such transition observed since 1963, according to researchers tracking the full historical record. A slower buildup gives the ocean and atmosphere more time to gradually adjust to a changing pattern, and it also gives forecasters more opportunities to revise and refine their models as additional months of data come in. A transition this fast compresses all of that adjustment into a much shorter window, which is part of why confidence in this event reaching very strong intensity has climbed so quickly, from odds in the 60% range just a couple of months ago to the current 81%, and why forecasters describe this event as still technically in its infancy, even as it already outpaces prior records, since the truly mature high-impact phase of a super El Niño historically does not even begin until several months from now. Forecasters are not expecting this event to peak this month. And understanding the timeline matters because the most intense impacts are still ahead of us rather than behind us. El Niño events almost always reach their maximum strength late in the calendar year, typically sometime between November and January, as the seasonal cycle of the tropical Pacific locks the pattern into its most intense phase. Current model consensus places this event's peak somewhere between October and December of this year, with individual forecasting models disagreeing only on the exact month, some pointing to November, others to December. The median projection across the most sophisticated models tracking this event puts the eventual peak at roughly 3.6 degrees Celsius, a full degree above the 2015 to 2016 record. An independent analysis suggests that around 91% of the individual model runs currently being tracked expect this event to exceed that existing record altogether. None of this is guaranteed. Forecast uncertainty at this range remains genuinely significant, and the ocean still has months left to behave in ways models cannot fully predict this far out. But the trajectory so far, developing faster than 1997, running hotter than 2015 at the same calendar point, and backed by subsurface heat already at record levels, is precisely why climate scientists are treating this as a serious, credible possibility rather than an exaggerated headline. The reason this matters well beyond the world of climate scientists is that a super El Niño does not just raise a single number in the middle of the Pacific Ocean, it reshapes actual weather on the ground across huge parts of the world simultaneously, and the effects are already visible in this year's own August forecast. NOAA's own outlook for this month gives the southeast and southern mid-Atlantic of the United States better than 50% confidence in above-normal heat, driven partly by dry soil and unusually warm coastal waters that El Niño itself has helped produce, while forecasting a stormier, wetter pattern specifically for the Northeast at the same time. The Plains and Midwest are expected to see below-average rainfall through the rest of the month, with Oklahoma and Texas carrying the highest confidence for significantly below normal precipitation of anywhere in the country. Looking further ahead, seasonal outlooks for the coming winter are already pointing toward a warmer-than-normal west, a more active storm track across the south, and an increased risk of significant snow events across parts of the eastern United States, a pattern broadly consistent with how previous strong El Niño winters have historically played out, including California, where the state's historically wettest winters cluster specifically in strong El Niño years. The Atlantic hurricane season offers one more clear example of how directly this single ocean pattern reaches into completely different parts of the climate system. El Niño tends to suppress Atlantic hurricane activity by increasing wind shear across the Caribbean and tropical Atlantic, the disruptive change in wind speed and direction with height that tends to tear a strengthening storm apart before it can properly organize. Multiple forecasting agencies, including NOAA and the Seasonal Outlook team at Colorado State University, cited this developing event specifically when predicting a below-normal Atlantic season well before this year's hurricane season even began. And that forecast has held up closely against what has actually happened so far, with total Atlantic storm activity running well below the long-term average for this point in the season. The same pattern works in the opposite direction across the Pacific, where lower wind shear and warmer water tend to fuel an above E average number of storms in the eastern and central Pacific basins. Instead, essentially the same single climate signal splitting the world's hurricane basins into one unusually quiet season and one unusually active one, depending entirely on which side of Central America a given storm happens to form. The impacts stretch well beyond North America, and in several cases, the risks compound rather than simply add up. A separate but closely related ocean pattern called the Indian Ocean Dipole is independently forecast to swing into its own positive phase and remain dominant from August all the way through December of this year, with forecasters placing the probability of a neutral Indian Ocean at below 20% for that entire stretch. A positive Indian Ocean dipole tends to reinforce many of the same regional effects a strong El Niño already produces, meaning the two patterns are not simply coexisting this year, they are actively stacking on top of each other. In Australia, that combination points toward a drier than normal east coast, primed wildfire fuels heading into the country's own fire season, and genuine concern for the country's wheat-growing regions heading into a critical part of the growing calendar. In India, where roughly 1 billion people depend economically on a single 4-month monsoon season for the bulk of their annual rainfall, strong El Niño years have historically tended to load that season toward a rainfall deficit rather than a surplus, a pattern meteorologists there will be watching closely as this event continues strengthening into the back half of the year. History offers a fairly direct preview of what a super El Niño winter is actually capable of producing once it reaches its peak. During the 2015 to 2016 event, Indonesia experienced such an extended, severe dry season that peat fires burning across the country released a volume of carbon dioxide roughly equivalent to Japan's entire annual emissions for that year. At the same time, on the opposite side of the Pacific, Southern California received more than 150% of its normal winter rainfall in some areas. A genuine relief for a region that had been suffering through years of drought, but a relief that came with its own serious downside, triggering floods and dangerous landslides across hillsides that had been freshly scarred by wildfire in the years before. That same event has been credibly linked to broader global consequences as well, including disruptions to agriculture and fisheries across multiple continents. If the 2026 to 2027 event genuinely does exceed that 2015 benchmark, as current model trajectories suggest it may, the reasonable expectation among the scientists tracking it is that these same categories of impact, drought and fire risk in some regions, flooding and landslide risk in others, could arrive at an even greater scale than what the world experienced during the previous record holder. There is a genuinely useful comparison sitting inside how different regions are approaching this event this time around, because a super El Niño, arriving with unusually early high confidence warning, gives communities a real head start. Most previous events never provided this far in advance. Water utilities across drought-prone parts of the American Southwest and California have specific historical precedent now to draw on. Since strong El Niño winters have repeatedly proven capable of delivering enormous rainfall totals, capable of both refilling reservoirs and triggering dangerous flooding in the same season, a dual outcome that reservoir operators can plan storage strategy around months in advance, rather than reacting to it in real time. Australian agricultural and fire agencies, watching both El Niño and a compounding positive Indian Ocean dipole develop simultaneously months before the country's peak fire season even begins, have a similarly unusual amount of lead time to preposition resources and adjust water allocation for farmers, compared with past events where the same combination was only confirmed once the dry conditions had already arrived. The regions likely to fare worst once this event peaks are not necessarily the ones facing the most extreme rainfall or drought in absolute terms, but the ones without the institutional capacity to actually act on months of advance warning that the scientific community is already providing this far ahead of the event's own forecast peak, a gap that has far more to do with infrastructure and planning than with the raw intensity of the weather itself. So what does all of this actually mean for you, wherever you happen to be watching this from? If you live in the southern or western United States, the practical takeaway is that current outlooks point toward a warmer, potentially wetter winter than normal, particularly across California and the south, a pattern worth watching closely if you live anywhere near a burn scar, a floodplain, or a hillside with a history of landslides. If you live in the eastern United States, the same event is currently associated with an increased risk of significant snow events this coming winter, worth factoring into any planning that depends on stable winter weather. If you live in Australia, India, Indonesia, or anywhere else in the broader path of this event, the historical pattern from the last two Super L Niño years suggests this is a season to take seasonal drought, fire, and monsoon outlooks unusually seriously, given both the current strength of the signal and the additional months of runway scientists are providing before its expected peak. And regardless of where you live, the single most useful habit sitting inside everything we just walked through is checking your own region's official seasonal outlook from a national meteorological agency sometime in the next few months, rather than waiting until the pattern has already fully arrived to start paying attention. The honest, grounded summary is this. A super El Niño event is currently developing in the tropical Pacific faster than either of the two strongest events ever recorded, 1997 and 2015, with the Niño 3.4 index already running hotter at this exact point in the year than either of those historic events managed to reach. Forecasters give this event roughly an 81% chance of reaching very strong intensity, with model consensus pointing to a peak sometime between October and December of this year, potentially reaching a full degree above the current all-time record. A separately developing positive Indian Ocean dipole is forecast to compound many of the same regional effects through the end of the year. The United States is already seeing early signs of the pattern in this month's own weather, with a hotter, drier southeast, and plains sitting alongside a stormier northeast, and seasonal outlooks pointing toward a warm west and an active southern storm track heading into winter. Australia, India, and Indonesia all face historically elevated drought, fire, or monsoon deficit risk based directly on how the last two events of this magnitude actually played out on the ground. The Atlantic hurricane season is already running below normal as a direct result, while the eastern and central Pacific basins see the opposite effect, evidence that this single ocean signal is already reshaping global weather months before it even reaches its own forecast peak. We are going to keep tracking this as the event builds toward its expected peak later this year, sourced the same way we did today, straight from NOAA's Climate Prediction Center, the international researchers actually running these forecast models, and the National Meteorological Agencies actually issuing region-specific outlooks, not recycled headlines. Subscribe so you do not miss the updates as this event continues developing, because based on everything the data currently shows, this is very likely headed toward record territory, rather than away from it. And leave that comment below. Tell me where you are watching from, and whether your own regional forecast has already started mentioning El Niño by name, because for a lot of people, that mention is about to become a lot more common over the next several months, because behind every one of these numbers is a farmer in India watching 4 months of rainfall decide an entire year's income, a family in Southern California hoping this winter's rain refills reservoirs without also bringing a landslide to their hillside, a wheat grower in Eastern Australia watching 2 compounding ocean patterns build at the same time months before harvest, and a climate scientist in Berkeley plotting a red line on a graph that, as of this week, is unlike anything in 45 years of records. 5,000 likes on this one. Let us go. See you in the next one.